This video is an explanation on the answers in quiz 1. If you cannot get the right answer to a particular question and you still can't figure out why the answer is so, this is a brief introduction to each question to see how do we come up to that particular answer. So let's start with question 1. If you look at the time mark at the bottom of the comments, you can jump directly to the question that you want to understand. Alright, so here comes question 1. Question 1 is very similar to the past paper questions. We have like two types of person. We have senior staff members, right, and junior staff members. For senior staff member, we choose two of them. Alright, and then for junior staff members, we choose 5 of them. So first of all, the question is it P or C, NPR or NCR? The second question is, do we allow repeats? Right? You have to answer these two questions. Now they are all different persons. Alright, so definitely we do not allow repeat. You cannot pick two same person into the junior staff members, right? You have to pick 5 different persons, of course. Now because they join a training program, right? The question does not specify the ordering of the selection. Alright, so there are 5 junior members. So who is the first one? Who is the second one? I don't care. Alright, as long as there are 5 members. So the ordering is not important. So we use combination instead of permutation. Alright, so we use combination. So here let's look at the senior staff member. There are 6 of them. Among the 6 senior member, we choose 2 of them. Alright, so the number of ways to do that will be 6C2. Alright, and there are 13 junior staff members. So among the 13 junior, we choose 5 of them. So the number of ways to do that will be 13C5. Alright. Now the last question is, now we have these two numbers. Do we combine them with and or or? Alright. That is, do we connect them with multiplication or addition? That is the last and the third question. Alright. Addition or multiplication. Alright. Now here we know that they are independent events. They are not mutually exclusive. Mutually exclusive means that if you choose senior, then you do not choose junior, and vice versa. If you choose junior, then you do not choose senior. That is not the case. We have both senior and junior members, right? So we choose and 2 junior and 2 senior and 5 junior. So and will be multiplication. Alright, so we multiply these two numbers. The answer goes to 19305. Alright, if you multiply these two numbers together. So this is question 1. Alright. Now we have question 2. Question 2, there are 15 different $1 coins and 9 different $2 coins. So imagine you have never mind the coin. So you have 15 A coins and 9 B coins. Alright. Now you choose 5 of them. So find the number of ways you can choose at least 3 $1 coin. Alright. So now at least 3 $1 coin. We try to expand the meaning of this one. Alright. 1 or A coin, or whatever. If you have at least 3, that means that can be 3 of them, right? There can be 4, there can be 5. Alright, 3 $1 coins, 4 $1 coins, or 5 $1 coins. It cannot be 6 because altogether you just take 5 coins. Alright. If there are 3 A coins, then there are 2 B coins. B coins, they are $2 coins. Alright, and then 1 B coin and no B coin. So there are 3 cases. Alright, we have case 1, case 2, and case 3. Case 1 is 3A and 2B. Case 2 is 4A and 1B. Alright. Now, each of these, they are either or. Either one case. If it is case 1, it cannot be case 2. If it is case 2, it cannot be case 3. Alright. So they are typical example of mutual exclusiveness. It is either case 1 or case 2 or case 3. If they use or to combine them together, we try to add them up. Alright, so we are going to add them up, these three cases. So the first one, we have 15 acorn, you choose 3 of them, so that is 15C3. Alright, you have 9 beacon, you choose 2 of them, that would be 9C2. Okay, once again, the last question is, do we add them together or do we multiply them together? Think about it. Is it and or? Is it 3A and 2B or 3A or 2B? Alright, now you have 5 corn, so obviously it is 3A and 2B. Alright, and means we multiply them together. So similarly, for the other 2 cases, it goes like this. Sorry, it should be 15. Alright, C4 and then 15C5. Alright, and we have 9C1 and then no B, so it's 9C0. Alright, 9C0 is 1, 9C0 is 1, so sometimes you can omit this one. Alright, okay, so all this you multiply them together. Alright, finally between the 3 numbers we add them together. Alright, so you can punch it on the calculator and the answer goes to 31668. Alright, this is the answer to question 2. Okay, now so we have question number 3. Alright, so there are 20 boys, alright, and 8 girls. Alright, 8 girls. So 4 students are chosen if it consists of no more than 2 girls. So once again, you have decipher the meaning of no more than 2 girls. What does that mean? Alright, no more than 2 girls. It can be 2 girls, that means, alright. So there's 2 girls, 1 girl, or maybe no girl. Alright, not more than 2 girls means there are 3 cases. We have case 1, case 2, and case 3. Alright, if there are 2 girls, that means there are 2 boys. Alright, 2 girls, 1 girl, or no girl. If there are 2 girls, that means we choose 2 boys. 1 girl means 3 boys. No girl means all 4 boys. Alright, so now if you have 8 girls, you choose 2, that would be 8C2. If you have 20 boys, you choose 2, that would be 20C2, and so on. Alright, the rest will be something like this: 8C1, 8C0. Alright, now we try to multiply each of these orange and blue numbers because they are connected with and. Alright, you can refer to question 1 and 2. However, between case 1, case 2, and case 3, they are either or. Alright, either one case. Alright, either one means that it is an or situation. So we add up these numbers. At the end, the answer is 19285. Alright, this is answer to question 3. Okay, we have question 4. A password consists of 6 digits, right? From 0 to 9, there are 10 of them, right? If the digits can be repeated, find the number of possible passwords. So imagine you have like 6 boxes for the passwords, 1, 2, 3, 4, 5, 6, alright? So think about how many choices are there in each box. Alright, now if you allow the digits to repeat, so for the first digit there are 10 choices. It can be from 0 to 9, alright, it can be 0, 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9, alright, altogether 10 choices. In the second box, there are another 10 choices because they can repeat, alright. And likewise, every box, there are 10 choices, alright, you can repeat the digit, right? So if you multiply them together, the answer will be 1 million in this question. 1 million. Right? There are so many different passwords you can make. On the other hand, if you do not allow repeat, if you cannot repeat, alright, cannot repeat, then you have 10 choices for the first box, and you are down to 9 choices for the second box, and so on. Alright, for each further box, you have 1 fewer number to choose from. So it's a multiplication of all these numbers if you do not allow repeat. Alright, so the answer in this case, if you do not allow repeat, will be 151,200 only. It's much smaller, right? Between allow repeat and not allow repeat. Right. On the other hand, if you if you do not allow repeat, this number is just 10p6. All right, you choose 6 digits out of 10 without repeating. All right. So question 4 actually is a challenge on whether you can repeat or you cannot repeat. All right. So that is question 4. Next we have question 5. There are 5 different eggs and 3 different lunch boxes. All right. If each lunch box contains 1 egg, so we can imagine we have these 3 boxes. All right. We have these 3 different boxes. Let's call them box A, box B, and box C. All right. You have 5 eggs, so let's call them eggs 1, 2, 3, 4, 5. These are eggs. All right. All right. So you just put the eggs in the boxes. This is it. All right. So how about box A? Box A, how many choices you can have in box A? You have 5 choices. It can be egg 1, egg 2, egg 3, egg 4, and egg 5. All right. 5 different eggs. Now in box B, because you have 1 egg already chosen, so box B is down to 4 choices. And likewise, box C is down to 3 choices. In other words, it is 5 times 4 times 3, alright? If you want NCR notation, that would be 5p3. You have 5 eggs, and you try to permutate 3 of them, alright? Because the 3 lunch boxes, they are different, alright? So the answer goes to 60, alright? On the other hand, if the boxes, they are the same, then we use 5c3. If they are same lunch boxes, then we use 5c3. If they are different lunch boxes, we use 5p3. Because if they are different lunch boxes, the ordering becomes important. So this is question 5. Next up, we have question 6. All right. Now, question 6, there are 2 different solutions. Let me show them to you one by one. All right. It depends on how you construct the weight of selection. So there are 8 boys and 6 girls in the table tennis team. A teacher wants to select 1 boy to play a single match. So how many ways he can do that? There are 8 boys. You want to select 1 boy. So there are 8c1 ways the teacher can do that. All right. Now, but after you take out 1 boy, now that is the most important thing in this question. There are now down to 7 boys and 6 girls to choose from. Alright, you have 1 fewer boy. Alright, so 7 boys and 6 girls remaining. Now you want to select 1 boy and 1 girl to play a mixed double match. So how many choices you have? Among the 7 boys, you can choose 1 of them. Among the 6 girls, you can choose another 1 of them. Alright. So now you multiply them together because they are all n. Alright, 1 boy and 1 boy for the mix and 1 girl for the mixed. 1 boy for the single in red, 1 boy for the mix in orange, and 1 girl in the mix in blue. Alright, you note I all set them with n. So if it is n, we multiply all of them together. So the answer goes to let me check. The answer goes to 336. Alright. Now on the other hand, you can do it in the reverse way. Alright. At the beginning, you can choose the mixed match first. You have 8 boys and 6 girls to choose from. Alright. You select the mixed double first. Alright. And that is the single team here. Alright. This is the single. Alternatively, you can consider the mixed double first. You can consider the mixed double. If you choose the boy and the girl from the mixed double, you have 8 boys to choose from. And then you have 6 girls, right? These are the number of ways you can select your mixed double team. Alright? And then now you come to choose the single player. Now because you have 1 fewer boy, you have only down to 7 boys. 1 of them is already chosen. So you have only 7c1 ways to do that. Alright. So the answer is also 336. No matter how you do it. No matter you think about the mixed double first and then the single. Or you choose the single first and then you choose the mixed double. The answer, they are both 336. Okay, so this is question 6. Alright, we have question 7. A lot of us did it wrong in question 7. So think about that, right? We have 4 doors, alright? We have 1, 2, 3, 4 on the left hand side, and then 3 doors on the right hand side. Alright, we have 2 persons, Irene and Simon. Irene and Simon going through one door and go out through another door. And then Simon will do something similar, alright, going through one door and go out through another door. The thing is, they will leave and enter the mall from different doors. So Simon and Irene, they will not use the same door. So how many choices do they have? Alright. First, think about Irene. Alright. Irene entering and exit. Alright. How many ways he can enter the mall? There are 4 different ways because there are 4 doors for her to choose from. How many ways to exit? There are 3 ways to exit. Alright. How about Simon? Now, because Irene already used up one of the doors, so Simon is only down to 3 ways to enter the mall. And likewise, because one door is already taken by Irene to exit, so Simon got only 2 choices in exiting. Alright. So we multiply all this together because they are connected with and. Alright, and they're not mutually exclusive. They are in fact independent. Think about that. So the answer is 4 times 3 times 3 times 2. The answer goes to 72. Alright. The answer is 72. Alright, so that is question 7. There is another way of thinking about question 7. If you label the doors like 1, 2, 3, 4. Alright. You pick 2 numbers from 1, 2, 3, 4. The first number will be Irene's entering. The second number will be Simon's entering. Alright. Imagine you have 2 boxes. One box is called Irene, one box is called Simon. Alright, can you do that? One box is Irene, one box is Simon. So you put the 2 numbers 1, 2, 3, 4 into these 2 boxes. This is about the entering. This is about the entering. Alright, you have these 2 numbers put into 2 boxes. How many ways you can do that? There will be 4p2 on the entering. Alright, you can Irene use 1 and Simon use 3. Or vice versa, Irene use 3, Simon. They are different, right? 3, 1 is not the same as 1, 3. So that's 4p2. So similarly, for the exiting, there will be 3p2. Alright. Exiting, there will be 3p2. Imagine the doors, they are being A, B, C. Alright. So you have once again 2 boxes, and you put A, B, C, the 3 doors, into the box Irene and Simon. So that will be 3p2. So the final answer will be these 2 numbers multiplied together. Once again, it is 72. I try to show you different answers, different ways to arrive at the answer so that you know better. Now we come to question 8. Alright, there are 6 different white balls and 6 different black balls in a bag. 3 balls are chosen. How many ways can the ball be? If at least 1 white and at least 1 black. So there must be at least 1 white, there must be at least 1 black. So there are 2 ways you can do that. It is either 2 white and 1 black, or 2 black and 1 white. Right? Or shall I put it like this? It is 2 white and 1 black, or 2 black and 1 white. Alright, so there's either case 1 or case 2. There are only 2 possible cases to have both colors. Alright, at least 1 white and at least 1 black. So let's see. To have 2 whites, that would be 6c2. Alright, to have 1 black, that would be 4c1. To have 2 blacks, that would be 4c2. 1 white, that would be 6c1. Alright, and between all these, we multiply them together. And between case 1 and case 2, we add them together. The answer goes to 96. Alright. Now, alternatively, there is another method we can do that. Alright. The other method being using unless. Alright. At least 1 white and at least 1 black. At least 1 white and at least 1 black means that there must be both colors. Alright. So unless it is all black or all white. Alright. Unless it is all black or all white. Alright, unless wins one minus. So we take all possibilities and subtract the all black and the all white. All possibility means that regardless of color, we have 10 different boards. Every time we choose 3 of them, there is to complete the entire probability. Alright. And then all white means that we choose all the 3 boards from the white. So that would be 6C3. All black means that we choose all the 3 boards from the black. So that would be 4C3. Alright. That is unless all white or all black. Alright. So the answer is the same, I believe. It's the same, 96. You can try it on the calculator. So that is question 8. Right. Now next up we have question 9. We have 7 different books divided into 1, 2, 4. Alright. So we have 7 books. Let's call the 7 books 1 to 7. Alright. We have book 1 all the way to book 7. 1, 2, 3, 4, 5, 6, 7. We want to split into 3 groups, 1, 2, and 4. Alright. So maybe we choose the 1 first, alright? So I choose 1 book to go into the singleton, to go into the lone book. So there are 7 C1 ways to do that. Alright, for example, I take away book 3, alright? And then think about group 2, alright? Group 2 will, the double book, alright? Now, I have now 1 fewer book to choose from because 1 book is already taken. So I'm now down to 6 books. Among the 6 books, I choose 2 of them, alright, into the red group. So that is 6C2, alright? And finally, how about the group of 4? Alright, the group of 4, the quadruples. We choose the remaining, alright? You have no choice. There is only one way to do that. You have 4 books remaining and you have to choose all 4 of them. And this is it. This is the answer. And the answer goes to 105. Alright? Note that you can do it in different ways. Say if I want to take the quadruple, I want to take the 4 books first, alright? So there would be 7C4 ways you can do that. Alright, there are 7 books and you take 4 of them. 7C4, alright? Now you are down to 3 books, alright, because 4 is already taken, so you are down to 3 books. Among the 3 books, you choose 2 of them, so that would be 3C2. And finally, there is only 1 book remaining, and you just choose that book, alright? I didn't do the calculation, but I believe it is the same 105. Alright? Or you can do it in different ways. You can try to the red group first, alright? You can try 7C2. Right? You take the 2 books first among the 7. And then you have 5 books remaining. Among the 5 books, you choose 4 of them. 5C4. And finally, there is only 1 last book and you just choose it. This is the same, alright? No matter how you put red, blue, green in whatever order, they should arrive at the same answer, alright? Say, let's try that again. Let's try the red, blue, green. Red, green, blue, alright? Red. Red will be 7C2. You have 7 books, you choose 2 of them. And then you have 5 books remaining, alright? You choose 1 of them. And then you have 4 books remaining, you choose 4 of them. Alright, no matter how you line up these 3 colors, they all arrive at the same answer. This is question 9. And then we have question 10. Question 10 says that there are 5 students selected from 15 to form a committee with a chairperson, a vice chairperson, and 3 secretaries. Now, perhaps some of us misunderstood the question. If you have the answer like 360, alright, then you misunderstood the question. Alright. In the original question, the idea was that the chairperson and the vice chairperson, they are 2 different poses. But the 3 secretaries, they are the same pose, alright? The 2 secretaries they do not classify themselves as the finance, the publication secretary, whatever, alright? The 3 secretaries, they are the same, alright? So the correct answer goes like that. First of all, you choose the chairperson. That would be 15C1. Alright, there are so many ways to choose the chairperson. How about the vice chairperson? The vice chairperson, you no longer have 15 to choose from because one of them is taken as the chair. So you have only 14C1. Alright, and the 3 secretaries, you have 13 to choose from. And among the 13, you choose 3 of them. and then they are independent choices, they are and situation. So we just multiply them together. The answer goes to 60,060. Alright, this is the answer. Alright, if you believe that the three secretaries are different, alright, they are like, one of them is the finance secretary, one of them is the publication secretary, one of them is the sports secretary, right? Then you have 5 different posts. The answer will be much simpler. If you all the 5 posts they are different, then the answer is 15p5. Alright, the 5 posts they're all different, and 15p5 is 360360. Alright, if you misunderstand the question in this way, you arrive at this answer. And then, like question 9, this red, green, blue ordering, you can change them. Say you choose the 3 secretaries first. Alright, then you have 15c3 ways. You can choose the 3 secretaries. Alright, and then you choose the vice chairperson. Now, because 3 of them is already taken, so you have only 12 persons to be selected as the vice person. Alright, and likewise you have yet 1 less person to choose from. You are down to 15 minus 4 will be 11 person, and you choose 1 as the president, as the chairperson. Alright, I believe I didn't work out the calculation, but I believe it is the same. Alright, if it is not the same, you tell me. Alright, so question 9 and 10, they are very similar. Alright, so this is it. I hope you can get the solution to all 10 questions. Thank you.